I hope you can see the screen, right?
Yes.
So today we will see more questions about the section 4.5 and 4.6. You know, in the section 4.5, we define the dimension of a vector space. So when we look at the exercise questions in here, we have very nice questions. We can improve our skill about this topic by solving more questions from here. Please look at the questions in here to improve your mathematical skill about this topic. You know, the dimension of a vector space, if you remember the definition, is the number of vectors in the basis of the vector space. Okay, the basic dimension, the number of vectors in the basis of the vector space. Dimension says how many components we should use for a vector in the vector space. This is the information. This is learned by finding the dimension of the vector space. So when we look at the first questions from the section 4.5, we see that some sets in here. So the question says, find the basis and state the dimension. So among them, I will solve the third one. So also you can find the others by using the similar way. Actually, we did questions also during the lesson. Please check the lecture notes to see the answer. For the question 3, 4.5, section 4.5, question 3. First, we need to find a basis for the set. The general vector for the set given here, 2c, a minus b, b minus 3c, 2c, a minus b, a minus b, b minus 3c, a plus 2b, a plus 2b. So how many variables do we have in here? How many unknowns do we have in here? So we have A, we have B, and we have C in here. Therefore, we can use the coefficients of them to find a basis to write as a linear combination the general vector. So A times, what should we say? Can you say? A times, what is the first number? There is no A in the first entry, therefore we write 0. The second one is 1, the third one is 0, the last one is equal to 1. For B, times 0 minus 1, 1, 2, plus C, 2, 0 minus 3, 0. Okay, so every vector in the set given in the question 3 can be written like this. When you compute the right hand side, you will get the left hand side. Therefore, we have this equality. Since every vector is written in this form, which is a linear combination of 3 vectors, so the given set, let's say the given set will be equal to span V1, V2, V3. What is V1? What is V2? V3, V1, V2, V3. Namely, the second condition is already satisfied in here, but also we should check whether they are linearly independent or dependent. For this, we write the corresponding matrix. First, I want to write the third one. There is no any definite order. You can write any of them for the first column. Since we have non-zero number in the first entry, this vector will be better for the first column than the others. Therefore, I am writing the third one first. 2, 0, minus 3, 0. 0, minus 1, 1, 2, 0, 1, 0, 1. How can we check? The columns are linearly independent or dependent. So for this, of course, we need to find the echelon form. So to get 0 for minus 3, or first we can write R1 is scaling by 1 over 2 to get 1. So we have 1, 0, 0, 0, minus 1, 1, minus 3, 1, 0, 0, 2, 1. So from here, R2, R3, because in the third entry we have non-zero number, is replaced by R3 plus 3R1. Therefore, we have 1, 0, 0, 0, 0, minus 1, 1, 0, 1, 0, 2, 1. And to get 0 for 1 and 2, because the second pivot is minus 1, first pivot, we write R3 is replaced by R3 plus R2. R4 is replaced by R4 plus 2R2. And from here, 1, 0, 0, 0, 0, minus 1, 0, 0, 0, 1, R3 plus R2. We have again 1, R4 plus 2R2. So we have 3 in here. And so actually they are linearly independent. First pivot, second pivot, third pivot, and easily you can make the number 3 0. The last operation will be R4 is replaced by R4 plus minus 3 R3 minus. Therefore, we have 1, 0, 0, 0, 0, minus 1, 0, 0, 1, 1, 0. First pivot, second pivot, third pivot, therefore linearly independent. So a basis for the set will be V1, V2, V3. Therefore, what is the dimension of the set? The dimension of the set will be 3, since we have 3 vectors in the basis. Okay. After finding the corresponding spanning set for the given set in the question, also you should check the first condition. What is the first condition? The vectors in the spanning set must be linearly independent. Or you should remove unnecessary vectors, which is corresponding to the column, not including the pivot position. But here we have pivot positions in every column, which means that there is no unnecessary column, unnecessary vector. We cannot remove any of them in here or in here. Therefore, we write all of them for the basis, which means that the dimension is also equal to 3. Okay. If you have any question, please ask. Don't hesitate. Yes.
Can you go a bit up to the beginning? Yeah. We have 3 vectors, V1, V2, V3. But why, when you create a matrix, you replace the third vector as a first column? And
Because
V1 to the
Yeah.
third column.
Because when you start the row operation, generally we want to obtain a non-zero number for the first entry, right? Here, for the first entry.
But we can take the second entry to the first entry. Just change the rows.
Yeah, you
columns.
can do this. This is not only way. There are a few ways. You can choose the first vector is the first column, the second vector is the second column, the third vector is the third column. But the order is not important. You can change the places of the vectors. The important thing is to obtain the last thing. Okay, this one. Of course, instead of V3, you can use also V2 as the first column. There is no problem. The computation will be same. As a result, consequently, you will obtain this situation. Therefore, there is no any definite order, certain order for the vectors. You can write also V3 will be V1. I can change the names of the vectors also. I can say this is V1. Okay. Therefore, I am writing as a first column. This is V2. This is V3. Is there any wrong when we assign a name for the vectors? No. You can choose any of them as the first vector. There is no problem. Why I am choosing the third one as a first vector? Because the first entry is non-zero. Shortly, I want to reach the echelon form. To reach the echelon form, I should reduce the steps. You see how many steps do we have in here? 1, 2, 3, 4, and in the fourth step, I can reach the echelon form. If you write the first vector as the first column, also you will obtain more steps than 4 steps. Maybe you will reach the echelon form in 5 steps, 6 steps, and so on, because we have 0 in here. Maybe you will apply also additionally interchange to get non-zero number for the first entry. Okay, that's why I am choosing the third one to reduce the steps. Another question? Okay. So this is the answer of the question 3. Dimension is 3 for this set. We have 3 vectors in the basis. That's it. Similarly, you will obtain the others in the final exam. If you have such a question, you will follow the same way. That's it. There is not hard for you, for engineers. Should not be hard. So when we look at the next one, for example, find the dimension of the subspace of all vectors in R³ whose first and third entries are equal. So we have a subspace, question 9. We have a subspace H such that the first entry and the third entry are equal to each other. How can we express this situation mathematically? There is a sentence in here. So how can we convert this center into a mathematical description? How can we do? So the dimension, find the dimension. So first and third entries are equal. In R³, how many elements, how many components do we have for a vector? How many components? 3. The first one is X, the second one is Y, and according to the given information, also the third entry will be X. Very good. So X, Y, X. X and Y are real numbers. It is a subspace of R³, okay. So how can we find the dimension? You know, we should find the basis of this subspace. How can we find? Actually, it is very similar to the previous solution. Instead of A, B, C, we have X, Y, X, Y. Therefore, X, Y, X can be written as X times. Can you say the entries? What are the entries? What are the entries?
101.
101 plus Y
010.
010. So now, since we have non-zero number here, I choose this is the first vector and this is the second. So H can be written as span V1, V2 because every vector in the set can be written as a linear combination of the vectors V1 and V2. Namely, the second condition is okay. What about the first condition? How can we say these vectors are linearly independent or dependent? Directly, we write the corresponding matrix 1, 0, 1, 0, 1, 0. Just we should get 0 for 1. The first step will be R3 is replaced by R3 minus R1. So we have 1, 0, 0, 0, 1, 0. First pivot, second pivot, which means that they are linearly independent. Therefore, a basis for this subspace will be also V1, V2. We have just two vectors in here. Therefore, what is the dimension? Dimension will be equal to 2. Okay? Sometimes, maybe, or probably, in the final exam, you can see such a question. There is just a sentence in here, and you should know, you should see the first and third entries are equal. So you should think the mathematical description of this sentence. You should convert this sentence into the mathematical object, as you can see, like this. And you should know which way is the true way to get the answer. Okay? So if you don't have any question for this, we can see another one. In exercises 11 and 12, find the dimension of the subspace spanned by the given vectors. Also, this is very easy for you. After seeing the previous questions, answer of the previous questions, just you will write the corresponding matrix. Okay, you will find the echelon form. Maybe first column, second column, and third column have the pivot position. The last one, there is no pivot position in the last one, so you should remove the last vector. The first three vector can be a basis for the subspace. Therefore, the dimension of this subspace will be 3. Okay, will be 3. Automatically, actually, you can say these vectors are linearly dependent. Why? Because we have 3 entries in each vector, 3 entries. But how many vectors do we have here? 4 vectors. If you remember, we wrote some theorem during the lesson. If the number of vectors is bigger than the number of entries in the vector, so you can say directly they are linearly dependent. Therefore, at least in one of the columns, there is no pivot position, which means that one of the vectors in here is unnecessary. Therefore, the subspace can be obtained by just using the vectors, including the pivot position, and the number of pivot positions will be also the dimension of the subspace. Okay. Please find the echelon form after finding the pivot position. you can see which vectors we should take and which vectors are unnecessary. You will follow the similar way for the question 12. For the next group, determine the dimensions of a null space and column space of the matrix A given here. So I will solve the question 14. Similarly, you can solve the others. Please solve yourselves to improve. Okay. You should solve more and more questions in mathematics to improve yourself. So, actually we did such a question during the lesson also. When we look at the matrix, I think it is already in echelon form, right? In echelon form. First pivot, okay, first pivot. All entries are 0 below the pivot position. There is no problem. This is the second pivot. All entries are 0. Okay, very good. This is the third pivot. In the second column, fourth column, and fifth column, there is no pivot. So what is the dimension of the column space directly? And dimension of the null space. Also, we can find the rank, if you remember. What is the rank of this matrix? Can you say?
3, because we have 3 pivot positions.
For the column space, right? For the column space. For the null space, what can we say?
It was again 3, I guess.
Because
we are looking for the columns that has no pivot position.
yeah, very good. In the second column, in the fourth column, and the in the fifth column and in the sixth column, there is no pivot. Therefore, it is equal to 3. Also, you can also say we have 3 free variables, right? 3 free variables. Therefore, the dimension of the null space represent the number of free variables. What is the rank? Do you remember the definition of the rank? We did an equation rank A plus dimension of the null space is equal to some number. What was this number?
Columns.
How many columns?
N.
N. What is N for this matrix?
6.
1, 2, 3, 4, 5. Yes, 6. Dimension is 3, null space. Therefore, the rank of A is equal to 3. Also, we know rank A is equal to the dimension of the column space. Also, it is equal to the dimension of the row space, right? Dimension of the row space. All of them are equal to each other. You should know. Of course, I can give a matrix and you need to find the echelon form like this. And then according to the pivot position, free variable, you can easily find them. So, question 22. We have special polynomials in here. They are called Leguer polynomials. 1 minus t, and so on. We have 4 polynomials, P1, P2, P3, P4. Show that these polynomials form a basis of polynomial space of degree at most 3. How can we show? They form a basis. Let's see. Question 22, section 4.5. Yes. P1t is equal to 1. P2t is equal to 1 minus t. P3t, what was P3t? 2 minus 4t plus t squared. 2 minus plus t squared. P4t is equal to P4 18.9 minus t. Minus t cube, I guess. Minus plus minus. Okay. 18.9. Okay, there is no problem. So show that beta, including them, P4, is a basis for the polynomial space, if you remember. It represents the set of all polynomials of degree at most 3. As you can see, at most the degree of a polynomial is 3 in here, as you can see. For this, we will use we will use the coordinate mapping. If you remember, you know, every polynomial is actually corresponding to a vector. In other words, you know, the polynomial space of degree at most 3 is equivalent to the real vector space r to the power 4, r to the power 4, because P1, for example, is corresponding to the vector. Actually, when we consider the general polynomial a plus a0, a1t, a2t squared, and a3 t to the power 3. How many coefficients do we have in here? We have 4 coefficients. Therefore, the corresponding vector, the equivalence, can be given as this polynomial is considered as a vector whose entries are a0, a1, a2, a3. So what are the entries for P1? What are the entries for P1? Can you say? We have 1, a0, 1. There is no t, there is no t squared, there is no t to the power 3. So what are the coefficients in this case? You know, we write 0, 0, 0. For P2, 1 minus 1, 0, 0. For P3, 2 minus 4, 2 minus 4, 1, 0. For P4, 6 minus 18, 9 minus 1. So to determine whether they are linearly independent or dependent, we will write the corresponding matrix. 1, 0, 0, 0. P1, 1 minus 1, 0, 0. 2 minus 4, 1, 0. 9, 18. minus 1. I think it is in echelon form already because this is the first pivot, all entries are 0, there is no problem. Second pivot, all entries are 0, there is no problem. Third pivot, 0, last pivot, minus 1. In every column, as you can see, we have pivot positions. Therefore, all polynomials are linearly independent. Linearly independent. Therefore, we have the first condition. What is the second condition? A polynomial space should be written as a spanning set of them, P1, P2, P3, P4. The equivalence of this equality can be stated as, actually, R to the 4 should be written as a set spanned by the corresponding vectors P1, P2, P3, and P4. Can we say this situation? Yes, because in every column we have pivot positions. Therefore, we have exactly one solution when we consider any vector in the vector space. It has 4 entries, any vector, any arbitrary vector. So we can consider B is a linear combination of the vectors according to the definition of spanning set, you know. C4, P to the P4. When we consider the corresponding matrix 1, 0, 0, 0, 1, minus 1, 0, 0, 2, minus 4, 1, 0, 6, 18, 9, minus 1, B1, B2, B3, B4. For every row, there is no impossible situation. We can find exactly one solution. Exactly one solution. Therefore, there is no problem for the second condition. So it is a basis. Beta is a basis. And the dimension of the polynomial space, that's why, is equal to 4. Okay? If you have any question, I can answer. This is an important question for the final. Okay? Please sign. So the question 24 says that beta be the basis of P2 consisting of the first 3 Laguerre polynomials listed here. There is a polynomial in here, so find the coordinate vector of P relative to beta. In other words, we use the first 3 vectors P1, P2, P3. When we look at the matrix here, if we remove yes, here. If we remove the last column, namely question 24, section 4.5, the corresponding matrix directly will be 1, 0, 0, 1, minus 1, 0, 2, minus 4, 1, okay? And you can see they are again linearly independent, P1, P2, P3, for the polynomial space of degree at most 2. It is corresponding to R3. Also, when we look at the entries of the columns, we can see this equivalence, especially for the given polynomial P. What is the polynomial? Let's see here. 7 minus 8 plus 3t squared. 7 minus 8 plus t squared. Yes. 3t squared. So the question is that find the coordinate vector of P relative to the basis beta. What is beta? Beta is the vectors P1, P2, P3 in here. And the coordinate vector of the given polynomial will have the entries C1, C2, C3, if you remember, such that polynomial P given here will be a linear combination of the vectors in the basis. Namely, the entries of the polynomial P relative to the basis beta will be weights of the linear combination, as you can see. Therefore, you need to find the solution, at least one solution in here. Actually, we will have exactly one solution. Please solve yourselves. 1, 0, 0, 1 minus 1, 0, 2 minus 4, 1. What is P? 7, 8 minus 8, 3, the coefficients here. And from here, you will obtain C1, C2, C3. You know, the first column is C1, the second column is C2, the third column is C3, and you will obtain the coordinate vector of the polynomial. Okay? Okay. That's it. I think we solved many questions from the section 4.5. Please look at the others. If you have any questions so far, I can answer. So let's see also the next section, 4.6. You know, in this section, we learn the rank. Then look at the exercise questions. So let's see the question 2. Assume that the matrix A is row equivalent to the matrix B. We have row equivalent matrices in here without calculations. List rank A, dimension null A. Actually, we solve such a question and find basis for column space, row space, null space. We did such a question in the lesson. Please look at the corresponding question from the lecture notes. Just I will say in here the dimensions. Please find also basis for column space, row space, null space. This question can be a final exam question, okay? Please sign also this question, final exam question. Since A is equivalent to the matrix B given here, how many pivot positions do we have for the matrix B? First pivot, second pivot, there is no another one. Here we have the number 5. We have 3 pivot positions. What is the dimension of the null space? What is the rank? 2. Rank is 3, right? Number of pivot positions, because the number of pivot positions gives the dimension of the column space, and the dimension of the column space is equal to the rank of the matrix A. And please find basis. You can look at the, as I said, please look at the question in the lecture notes. This week we completed. For the next question, because the others are similar in here, please discuss together yourselves 3 question 4 maybe. I can ask one of them in the final. The question 9, if the null space of a 5 by 6 matrix A is 4-dimensional, what is the dimension of the column space? What can we say? We have a matrix 5 by 6. Dimension of the null space is equal to 4. What is the dimension of the column space? You know,
2.
2. Let's see. You know, rank A is equal to the dimension of the column space. Actually, we did many times this question. Is equal to n. What is n? N is the second number in the size of the matrix, which gives the number of columns. Therefore, we have 6 in here, and we know the dimension of the this one null space should be null space. Sorry, null space. We know the dimension of the null space. It is equal to 4. It is equal to 4. Therefore, rank A becomes 2. And you know, rank A is also equal to the dimension of the column space. That's it. There is no problem. The others are similar. Please discuss yourselves. Others are similar here. When we look at the question 15, if A is a 6 by 8 matrix, what is the smallest possible dimension of the null space? Minimum of the dimension of the null space. What can we say? Smallest possible dimension, the smallest possible dimension of null space. The matrix is 6 by 8. 6 by 8. Smallest possible dimension of null space. And you know, did you find the answer? Rank A plus dimension null A is equal to n. What is n?
8.
8. N is 8. So our purpose is to find the minimum value of the dimension of the null space. To get the minimum value, so rank A should be maximum, right? Rank A should be maximum to get the minimum value of the null space. What is the maximum value of rank when we consider the size?
6.
Very good. Because, can you say the reason?
Because since we have, let's say, 6 rows,
Yes.
there should be pivot positions, and considering that, we will receive 6 pivot positions.
Yeah. Very good. Very good. This is the reason.
But not more.
Because at most we can have 6 pivot positions, right? Since we have 6 rows. Very good. So this is the maximum value of rank. That's why the minimum value of dimension will be 2. Okay, did you understand? For the next question, what can we say? Now the size is 6 by 4. 6 by 4. What can we say? Please consider the same question. What is the maximum value of rank?
4.
4. Very good. Not 6, right? Because we have actually 4 columns. Even if we have 6 rows, therefore at most we can have 4 pivot positions, which means that the rank can be maximum 4. And 4 dimension of null space is equal to n. What is n for this matrix?
4.
4. Therefore, the minimum value will be 0, right? For the next question. 0, 0, 2. Actually, the maximum value of rank is the minimum of two numbers in the size. You see, what is the minimum of 6 and 8? It is equal to 6. What is the minimum of 6 and 4? It is equal to 4. Automatically, you can think this situation to find the maximum value of the rank of the matrix. Okay? And okay, I think it is enough for this recitation hour. If you have any additional question, I can answer. Or if you don't have, we can finish here. Thank you very much. How many people do we have here? Okay, very good. Do you have any question? Ecanur, Şevval, Zeynep, Beyza.
Thank you.
Okay, thank you very much. See you.
See you.
See you.
Thank you, Dastan. You are very helpful. Eminhan, thank you very much.